Today we got problem 3634 minimum removals to balance array. You are given an integer array nums and integer k. So an array is considered balanced if the maximum element is at most k times the minimum. So here minimum is 1 and maximum is 5 and k is 2. So if 1 would 5 is more than 1 times k. So what can we do? We can remove any number of elements without making it empty. To make it balanced, of course, array of size 1 is balanced because it's equal to itself, so k1 is enough, but k is always 1. And we need to return the minimum number of elements to remove so that the remaining is balanced. Now, what does it mean? Right, that we remove some elements and then min max. We care about min max. Well, if we sort them, right, then let's say okay, so and we try all minimums, right? So let's say we sort these guys, right, and then we start with minimum is 1, and then we move the pointer until we get 1 times k is 3, so we get number larger, so that 1 2 6 9, so then it's 6, and these elements inside is what we can keep if minimum is this, and everything else to left to right throws out. So we move the pointer to left, and now the right pointer stays at the same place, doesn't have to move left, only right if necessary, like if it's possible, because we increased minimum. So the maximum value possible, like minimum increase, so minimum times k also probably increased, right? So that's it. Let's do it. Nums size, and then sort nums begin, nums end, and then for int, let's call it L, R is 0, ln, L++, while Rn and nums one long, no, nums R is smaller than or equal to 1 long times nums L times k. I think this should work, but I'm not sure. We'll see. Then we just do R++, and then we have some sort of answer, and then ans min ans, and now it's n minus R minus L, I think, and we return answer. Let's see. Oh. Okay, that should pass immediately. Nice. Let's go. So sorting plus sliding window and login intuition. If we sort the array, we can try each minimum going from left to right, and for each of the minimums find the last position find the maximum max nums L, no, min, find the maximum, find the largest max such that min times no, k times min max. All elements before min and after max have to be thrown out. Finally, we take the minimum number of elements needed to be thrown out over all minimums. Notice that maximums are non-decreasing for non-decreasing minimums, meaning we can use a sliding window approach where one pointer points to the minimum and increases by 1 every time, and another pointer pointing to the maximum, which increases until the condition holds, and then we keep elements in nums R. Time complexity n log, where n is the size of nums since we first sort the array and then move both pointers at most on times. No. On times, doing O1 update of ans for each window, of which there are n O1, since we only use a couple of extra variables. Okay, so that's a medium problem for today. Goodbye.